Welcome to Corrosive Online Tutorial. As you can see, our topic for today is the law of indices. This class is part 1, and in part 1 I'll be discussing the laws of indices. In the part 2 we'll be solving different problems that concerns indices. So, laws of indices. Now, for us to understand this topic, you know what is law. Law has to do with rules and regulations. Now, for you to understand indices, there are 6 basic laws of indices you must understand before you can solve any problem on indices. There are 6 basic laws. Number 1 is the law of multiplication. The law of multiplication. That is the first law of indices. And what does this law say? It says that base x raised to power p times base x raised to power q. You can see that these two terms have the same base with different powers. Okay? It said it is equal to x raised to power p plus q. Okay, that means you add the power. When you have the same base, you add the power, and that's what we call the law of multiplication. For example, I can say 2 raised to power 4 times 2 raised to power 6 or 2. If I want to apply this law now, since they have the same base, you can see the base is 2 and different powers, I can apply the laws of multiplication, which means I can say 2 raised to power 4 plus 2. And you know 4 plus 2 is 6. So the next line of action will be 2 raised to power 6. And 2 raised to power 6, please take note of this. 2 raised to power 6 is not 2 times 6 to give you 12. No. 2 raised to power 6 is 2 in 6 places. That is 2 times 2 times 2 times 2 times 2 times 2. If you count the 2, there are 6. 1, 2, 3, 4, 5, 6. So 2 raised to power 6 will be 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, 32 times 2, 64. And that will give us 64. So our answer is what? 64. So this is the law of what? Multiplication. Now, the second law we want to consider of the second law of indices is the law of division. Is the law of division. The second law is the law of division. Let me write on board. Law of division. Of course, you know what it means, division. And it says that base x raised to power p divided by base x raised to power q. Now, since we are applying division now, here will be minus. For example, you have x, p minus q. So you subtract from the power. Okay? Now they have a common base, you take it, then you subtract from the power when here is division. So it's called the law of division. Okay, for example, I can have 3 raised to power 4 divided by 3 raised to power 2. If I want to apply the law, this will be equal to 3 raised to power 4 minus 2. And 3 and 4 minus 2 will give us 2. So it will be 3 raised to power 2. Again, 3 raised to power 2 is not 3 times 2 to give you 6. No. 3 raised to power 2 is 3 in 2 places. So 3 times 3. 1, 2. You can see it. So 3 times 3 is 9. So our answer is 9. I hope that is understood. Now let's go to the third law of indices. The third law of indices is the law of brackets. Is the law of brackets. Is the law of brackets. The law of brackets. Of course, you know what a bracket. For example, I can say x raised to power p bracket raised to power q. Now, so when you want to open the bracket, you multiply the powers. Don't use this power to multiply this base. No. Use the power to multiply the power. So when you have something like this, to open the bracket, you're going to have x raised to power p times q. So that is the law of what? Bracket. For example, now, I can have 2 raised to power 2 bracket 3. This 3 is raised to power, the 2 is raised to power, but this 2 here is the base. Now, what do? You open the bracket. Okay, open the bracket. That means 2 times 3, you get 6. So it will now be 2 raised to power what? 6. And 2 raised to power 6 is not 2 times 6 to give you 12. No. 2 raised to power 6 is 2 in 6 places. So it's 2 times 2 times 2 times 2 times 2 times 2 in 6 places. So that will give us 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, 32 times 2, 64. So our answer will be what? 64. Now, I hope that is understood. Now, let's see the fourth law. The fourth law of indices is the law of negative power. The fourth law of indices is the law of negative power. The law of negative power. The fourth law of indices is the law of negative power. For example, now, if base x raised to power minus p, you see, in indices, we don't like negative sign. So what we try to do is to remove the negative sign. Okay? And to do that, you introduce an inverse. That means 1 over x raised to power what? P. So the minus has to disappear because you are applying what? The law of negative what? Powers. That means this is equal to this. Okay? This is equal to this. For example, I can have 5 raised to power minus 3. You see, there's no way I can solve until I remove the minus. And to remove the minus, I will introduce an inverse of the base. So 1 over 5 raised to power what? 3. And that will give me 1 over 5 raised to power 3 is 5 in 3 places. That is 5 times 5 times 5. And that will give us 5 times 5 is 25. Times 5 is 125. So my answer will be 1 over 125. I hope that is understood. Now let's go to the fifth law. The fifth law of indices. The fifth law is the law of power of 0. Is the law of power of 0. In this case, is when the power is 0. You know, in indices, you always have the base and the power. Now, this law is called the law of power of 0. Now, let's see what the law says. Say x raised to power 0 is equal to 1. That's the law. Very simple, direct. Anything raised to power of 0 is 1. 1 raised to power of 0 is 1. 2 raised to the power of 0 is 1. Even 1,000 raised to the power of 0 is 1. 1 million. 1 million raised to the power of 0 is 1. Anything raised to the power of 0 is 1. Even human being raised to the power of 0 is what? Is 1. So that is the law of power of what? 0. I hope that is understood. Now let's go to the sixth law. The sixth law. The sixth law is the law of fractional powers. Is the law of fractional powers. That which means that if you have something like this, base x raised to power p over q, you see that the power is a fraction. Unlike the previous one, the power here is a fraction. Now, for us to express this q, which is known as the denominator, with somersault to the other side. So you now have a square root of q, then x raised to power what? P. Okay? That is it. This one, with somersault to the other side. And you have a square root of that. Of course, this square root means 2. For example, now, I can have something like this. 25 raised to power 1 over 2. You see, 2 is already square root, so you don't need to write 2 here again because the whole thing means 2. So it means that it is the square root of 25 raised to power 1. This one here. Don't go and write 2 here because this whole thing, this square root represents 2. But if it is 3, you can write 3. If it is 4, you can write 4. But for these 2, don't write. For example, if I can have like this, 8 raised to power 1 over 3. In this case, this is not 2. So it's, in my square root, it will reflect there. So you have 8 raised to power 1. So this one will reflect there. This one will give me 5, of course. Square root of 25 is 5. Okay? Then this one, you can break this one down. Okay? This one is 2 raised to power 3. 2 raised to power 3 will give you 8. 2 times 2 times 2 times 2. I mean, 2 raised to power 3 will give you 8. 2 times 2 times 2. So I express my 8 in index form in order to cancel this square root. Okay, so 2 times 2 is 4. 4 times 2 is 8. So you can see in the next line is 2 raised to power 3. This 3 can, because this one is power, this one is power. So the power can cancel each other to give you 1. And 2 raised to power 1 is 2. Because anything raised to power 1 is that thing. And my answer is what? Is 2. I hope you enjoyed this video. Please, if you like my video, subscribe to my YouTube channels and also recommend these videos to every science student you know that is preparing for one exam or the other. Till we come again to see my next video when I will be solving problems on indices. Bye for now. Thank you. God bless you.